All right, so moving on, try and finish this before school starts. A ladder of length L leans against a vertical wall. The foot of the ladder makes an angle of 70 degrees with the ground. How far is the foot of the ladder from the wall X? So we make the angle with the ground, and ladders lean. And then I guess we do trig. What do we want here? We want the wall to be X. And this is L. And this is G. I noticed none of these involve G, so anyways, some of y'all like law of sines, some of y'all like SOHCAHTOA. I'm just going to do SOHCAHTOA. So I know I have opposite and hypotenuse. The sine of 70 is equal to x over L. And what am I doing here? How far is the foot of the ladder from the wall? Actually, I can't read. This is what they want to be x. It is, isn't it? Sorry about that. We have adjacent, which is going to be the cosine ratio. Cosine of 70 degrees equals x over L. And all I gotta do is L both sides, and I'm done. X is L cosine of 70. Simplify the sine of 2x over 1 plus the cosine of 2x. So on a problem like this, what you're going to do is you're going to look at your reference sheet. Sine of 2x, 2 sine t cosine t. So 2 sine x cosine x. 2 sine x cosine x. 2 sine x cosine x over 1 plus the cosine 2x. That one should have choices, but let's see what's on our reference sheet. If I can find it. Cosine of 2x. Ah, they're using that one. Cosine squared minus sine squared. I was hoping they would use a different one. Because there's like 3 of them. But that's the one they're using. Turds. Let's just do this one. Is that going to help me at all? Let me think. Sorry, I had a brain fart. Anyways, we're going to use the one they suggest. I don't know why I had a brain fart, but I did. They're doing it's cosine squared x minus, right? Should be a minus symbol. My brain hasn't woke up yet. Yes, it is. Minus. So what's going on this one? Think about the old default Pythagorean identity. Sine squared plus cosine squared is 1. Just think about that one and look at what you have. And if I move this over, I have cosine squared of x is 1 minus sine squared of x, which I could do. So I see I have a 1 minus sine squared of x. And look at that as cosine squared of x plus 1 minus sine squared of x. So this piece can become cosine squared. So what I have is I have 2 sine of x, cosine of x, sitting over cosine squared plus cosine squared, which is 2 cosine squareds of x. Get that down where you can see it. And now I'm in a position to do a little simplification, right? The 2's cancel, cosines out, and I now have sine of x over cosine x, which is tangent x. Ta-da! All right, so moving forward here. Simplify 1 plus tangent squared times 1 plus cosine of 2x. And let's use our substitution that we have. Again, if we look at it, it's over a reference sheet, if you're anything like me this morning. So cosine of 2x should be cosine squared minus sine squared. Now we'll do the same prop substitution we did earlier. That's right here. Cosine squared is 1 minus sine squared. So 1 plus 1 minus sine squared x. Or I could do a different one. Sine squared would be 1 minus cosine squared. Let's do that one. Let's do that sine squared of x is 1 minus cosine squared of x. I think it'll clean up better. Let's use this. 1 plus tangent squared of x times 1 plus cosine squared of x minus 1 minus cosine squared of x. It may not make a little bit of a difference. I don't know. I just thought if I did this, the ones would cancel. That's all I was thinking. And then cosine squared, take away a negative cosine squared, is 2 cosine squareds of x. And now I've gone from something that requires the double distributive property to the singular distributive property. And I'm going to distribute, and I'm going to see what happens. All right? There's 2 cosine squareds of x plus 2 cosine squareds of x tangent squareds of x. And I know that tangent squared is sine squared of x over cosine squared of x. So I got 2 cosine squareds of x times that. Gone. And I now have 2 cosine squareds of x plus 2 sine squareds of x. And here's finally the solution. I know that sine squared of x plus cosine squared of x is 1. So I pull the 2, then I have cosine squared of x plus sine squared of x, and I have 2 times 1, which is 2. Holy moly. Riveting. I feel like a genius right now. It's exactly the ego boost I needed this morning. Find the exact value of the arc cotangent of negative 1 over root 3. Do remember your acronym that all strippers take: cash. And the tangent ratio is allowed to be negative here and here. Now, arc cosine is defined in quadrants 1 and 4. So this is where we're going to draw. That's where we're going to draw it. I don't think it actually matters where you draw it. But anyways, hopefully you recognize you're probably dealing with a 30-60-90 pattern. I hope you do. The cotangent ratio, if you do your SOHCAHTOA, a cotangent would be AO. So adjacent is a 1, and opposite is going to be the negative root 3 because we have to fall. That is a 30-60-90 pattern. So be thinking about your 30-60-90 patterns you guys have memorized. Opposite of the 30 is the 1. Opposite of the 60 is the root 3. Hypotenuse is 2. All right. So here I know I have a 60-degree angle. And it's rotating that way. And we know our trigs, we know our radians, we know all that good stuff. We know 60 degrees is negative pi over 3. Moving forward. More trig. Simplify 1 over 1 plus the cosine of negative x plus 1 minus the cosine of x. So I'm thinking about this even identity that the cosine of a negative angle is the cosine of a positive angle. So I'm just going to get rid of that little symbol there and make it positive. And now what I'm going to do is I'm going to add 2 fractions together. Now if you take a half and a quarter and you add them together, the shortcut is to give that one a 4, give that one a 2, and then multiply the denominators together. So we're just going to do the shortcut. So this one is going to get 1 minus cosine x. Plus, because there's a plus, that one is going to get 1 plus cosine of x. and the denominator is the product of these two things. Now, if you're thinking the word conjugate like I am, we're on the same page. These are conjugates. Beautiful, because on conjugates, all that matters is first and last. So we do 1 times 1. I guess I'll do that over here. 1 times 1 is 1. And a positive cosine times negative cosine is minus cosine squared of x. In the numerator, we have 1 plus 1, which is 2. We have a negative cosine x plus a cosine x, so it's just 2. And then we're thinking about the old default sine squared plus cosine squared of x is 1. And we're thinking about, what if I move that over? Well, it turns out I have 2 over sine squared of x, which is going to be 2 cosecant squareds of x. So 2 cosecant squareds of x. Simplify the cosine of negative k times the sine of 2k minus the sine of negative k cosine of 2k. So I'm going to make this positive because I can. And I'm going to use the identity here that lets me say that the sine of a negative angle is the negative sine of a positive angle. So this is just going to become plus sine of k. And we have cosine sine plus sine cosine. Cosine sine plus sine cosine. We have cosine sine plus sine cosine. It looks a lot like this one, but it's out of order. Cosine sine plus sine cosine. Shouldn't matter. I mean, it can be rewritten. You can think of this as sine 2k cosine k plus cosine 2k sine k. So it looks like all I got to do is I got to add these two things together. If I'm looking at my reference sheet, S is 2k and T is k, and it turns out this is just the sine of S plus T, which is going to be the sine of 2k plus k, which is the sine of 3k. Whoops, and you didn't see me do a lick of work because I didn't transfer over. So, sorry about that. So let me go over that again. After I did a rewrite, I rewrote it to look like it should look on the formula sheet. Because the formula was sine, cosine, cosine, sine. I just swapped these things around. And S would have been 2k, T would have been the k, which is the sine of S plus T formula. And I just add 2k and k together, and I bam, sine of 3k. All right, use the appropriate sum or difference identity to find the exact value of the cosine of 7 pi over 12. And this is the one that bothered a lot of y'all, and heck, it bothered me too. It's how they have the answer choices written. Apparently, I'm supposed to teach something called, I even forgot the name of the theorem. And I don't have enough time to teach you that theorem. It's not actually too hard, but I don't have a day of instruction. So anyways, first off, this is the cosine of 7 pi over 12. Negative angles, make them positive with cosine. That's what you do. Secondly, you might want to know what she is as a degree. I don't know. Might make your life a little easier. 7 times 180 because pi is 180. Sitting pretty over 12. Do some reduction. 12 and 180 are both divisible by 6, right? So that's 7 times 30 over 2. 210 over 2, which is 105 degrees. That 210 is the moneymaker right there. 210 is something you know something about. You know something about it because it's on the unit circle. It is, isn't it? I feel like it is. 210 degrees would be about right there. And her ordered pair would be negative root 3 over 2 and 1/2. Now, why am I saying 210 is the deal breaker here? I'm saying 210 is the deal breaker here because I have a formula for this. If I look at my reference sheet, it's that one. The cosine of t over 2 I'm writing it down right now. Plus or minus 1 plus the cosine of t over 2. All right, so back to my scheduled programming here. Now, I'm over here, and I know that cosine is negative. Since I know cosine is negative, it's not going to be choice A. That's going to be negative. Or sorry, that's a possibility. That's a maybe, because it's negative. No, that's positive. Root 6 minus root 2 is going to be positive. Root 6 plus root 2 is going to be positive. So my choices are A and E. Those are maybes. Like knowing that you're positive made this a 1 in 5 to a 1 in 2. It's most likely choice A. So anyways, let's figure it out. In order to do a 105-degree angle, I have to plug 210 into it. So I'm actually finding the cosine of 210 over 2. And it's going to be the negative result of the square root of 1 plus the cosine of that angle, which is, anyways, let me do the whole thing here. Getting ahead of myself, over 2. So the cosine of 210 over 2 is equal to the negative radical of 1 plus a negative root 3 over 2, all over 2. I'm going to clean that up just a little bit. I'm going to distribute that 2 to both pieces. So the negative square root of 1/2 minus root 3 over 4. And then I'm going to clean it up a little bit more. I'm going to make this 2/4. 2 minus root 3, both over 4. And that's about as far as I've shown y'all how to take it. It is. So here's what we're going to do. I think that the negative root 2 minus root 3 over 4 is equal to root 2 minus root 6, also sitting pretty over 4. So what I'm going to do is I'm going to square both sides. That's a legit move. As long as you do the same thing to both sides, you still have equality. So a negative squared is positive. This root disappears. This is 2 minus root 3 over 4 now. In my brain, or off to the side, I have to do root 2 minus root 6, which is going to be 2 minus a root of 12 minus another root of 12. So minus 2 roots of 12, and then plus 6. And when I do the 4 squared, I'm sitting over 16. Now, I know that root 12 is root 3 times root 4, which is 2 root 3. So I'm actually taking away 4 roots of 3. 2 plus 6 is 8. And I'm taking away 4 roots of 3, and everything's over 16. All right, we're getting there, right? All 3 of these pieces are divisible by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. 16 divided by 4 is 4. And so this reduces down into 2 minus root 3 over 4. So yes, they are equivalent. And I wish I had time to teach you that theorem. I had no idea I was supposed to teach that theorem. I apologize. But I want you to focus on the fact that since I knew the answer was negative, that was my answer. Pay attention to that. All right, what is the range of the function the cosecant of 2x? Now, you may or may not remember this, and I don't have time to do the complete graph, but the cosecant function, what it did is you drew sine first. So you drew your sine function, and then what you did is every time you crossed the x-axis, you drew in some vertical asymptotes, and it was these parabolas. Now the sine function had a range from -1 to 1. So the cosecant function is going to be from negative infinity to negative 1 and from 1 to infinity. Find the period and the phase shift of 2 sines of 3x plus pi. Man, it's 7:30 already. So since it's sine, a normal period is 2 pi. That's what it is. But our period is going to be 2 pi over b, which is 2 pi over 3. So those two are gone, right? So one of these three. Now, what we need to do is we need to factor this piece. We need to pull that 3. And if we pull that 3, we have x plus pi over 3. Now, your phase shift is always opposite. So your phase shift is negative pi over 3. Choice C. That's really all there is to it. Not a hard problem. I'm down to about 10 minutes before Kyle starts beating on my door wanting in. Find the general solution to the equation 2 cosines of twice theta plus 1 equals 0. All right. Again, look at your formula sheet, but your formula sheet says the cosine of twice theta is, I don't even know, should I do this? No, I don't need to do this. I'm just going to subtract cosine of twice theta is negative 1. I'm going to divide by 2. So I'm going to get negative 1/2. Now they want a general solution. This thing's period is going to be 2 pi over 2. So pi. It's going to cycle pi. Remember doing general solutions where we would add k pi? It's just going to cycle like that forever and ever and ever. We're going to add k pi because we have a period of pi. That's our repetition cycle. So it's going to be C or E. I made it 50-50. Now what we're going to do is we're going to think about unit circle and where is the cosine ratio negative 1/2. Like where does that happen? It's going to have to be somewhere over here and somewhere over here. I believe that's the gist of it, isn't it? We have some funny answers here. Oh, and also don't forget this. What we're going to do is we're finding out where 2 theta, that's the deal, 2 theta is. That's what's throwing me off. Anyways, negative 1/2. I feel like it's at 120 degrees. It's 120 degrees or 2 pi over 3. And down here, struggling today, aren't I? 240? Seems right. 240 degrees, which is going to be 4 pi over 3. So what we found is we found that 2 theta must equal 2 pi over 3, or 2 theta must equal 4 pi over 3. If we divide out our 2, we get pi over 3. If we divide out our 2, we get 2 pi over 3. So choice C. Now, honestly, this one was just a dumb one. You would have never associated negative 1/2 with pi over 2. All right, find the exact value of the tangent of the arc sine of 1 over root 2. So this is just a simple first quadrant drawing. Sine, by the way, is opposite over hypotenuse. There's theta. Opposite is a 1, hypotenuse is root 2, and you should know the rest of this pattern. It's a 1, that's 45, 45, 90. And I want the tangent ratio, by God, it's 1. 44, for what values of x on the interval negative pi to pi does the graph of f of x equal cosecant of 2x plus pi over 2 have vertical asymptotes? And the angles are measured in radians. All right, so what we're going to do is we're going to rough graph the sine of 2 times x plus pi over 4. I'm going to factor. This thing has a period equal to 2 pi over 2, which is pi, and has a phase shift to left pi over 4. So I'm going to make my first indentation at negative pi over 4. I'm going to handle my phase shift. And then I'm going to go out pi. That'd take me out to 3 pi over 4. Halfway between these two things, it should actually be pi over 4, shouldn't it? I need 1, 2, 3, 4. That'd be 0. Pi over 4, pi over 2. Okay, that's not too hard. Let's put our 1's in place. 1 and 1, negative 1 and positive 1. And the sine function starts in the middle, rises, falls, falls, rises. Perfect. Your asymptotes are going to be where you cross the x-axis. Now, here's the other issue. I was supposed to go from negative pi to pi, and I did not do that, did I? Sure did not. But what have I written down? I've written down negative pi over 4, pi over 4, 3 pi over 4, 1, 2, 3. I got those three, it's that one. Because if I'd have continued graphing, I would have gone to negative pi over 2, and then I would have gone to negative 3 pi over 4. I would have fallen and risen, and I would have drawn another asymptote. So it's choice D. 45, using the law of sines to find the missing side B, round your answer to the nearest decimal digit. And law of sines is on your test. Why wouldn't it be? The deal is you're going to answer appropriately. Like you're just going to answer what it is. So I know that the sine of 60 degrees, which is something I can actually evaluate by hand, compares to 5, as the sine of 50 compares to side B. I'm going to use uppercase, even though I shouldn't. So if I cross multiply B sines of 60, which by the way I'm going to do something with, is equal to 5 sins of 50. So B is 5 sines of 50 over the sine of 60. Now, this is a good answer. A better answer, I know what the sine of 60 degrees is. Sine of 60 is root 3 over 2. So B is going to be 5 sins of 50 divided by root 3 over 2. I'm going to I'm going to flip. This is going to be 5 sines of 50 times 2 over root 3. So I'm going to have 10 sins of 50 sitting over root 3. And then I'm going to root 3 top and bottom, because why the heck not? 10 root 3 sines of 50 sitting pretty over 3. That is as far as you can take that without technology. All right, suppose that the sine of an angle is negative 2/5 and the angle is in quadrant 4. Evaluate the secant ratio. Secant, by the way, is the funny guy. So, anyways, I'm in quadrant 4. I'm down here. This is where I'm going to draw my little triangle. There's theta. Sine ratio is opposite over hypotenuse, so negative 2 over 5. I need to do a little Pythagorean theorem. Negative 2 squared plus 5 squared is, oh, nope. Negative 2 squared plus a squared is 5 squared. 2 squared is 4, 5 squared is 25. Difference is 21, so a is the root of 21. Direction matters, it is positive. So now I can do the secant ratio. The secant ratio is hypotenuse over adjacent, which is 5 over root 21. They didn't even clean it up. Only got a few minutes where Kyle insists on coming in. Find all the solutions to the equation tangent of theta is negative 1 over root 3 over the interval from 0 to 2 pi. So the tangent of theta would now be 1 over root 3. And you know your unit circle. Like you know it. Shouldn't be an issue. But it might be. I don't know. If you think about your unit circle stuff, the tangent of an angle is y over x. That's what she is. So what I'm doing here is I'm thinking about all the places, first off, where tangent is positive. It's going to be here and here. So there's going to be two answers. And it talks about an interval 0 to 2 pi, so this guy is nonsense. Nonsense, because I have to have how many answers? 2, that's right. Now I'm thinking about my unit circle, and I'm thinking about some key points here. Tangent is y over x. It's not that one. It's this one, which is going to be 1/2 root 3 over 2. And the reason I'm saying this is because I'm dead wrong. It's this one. You take 1/2 and you divide it by root 3 over 2. The 2's cancel and you get 1 over root 3. So it's this one and its corresponding one down here. So this was 30 degrees, which is better known as pi over 6, and this is going to be 7 pi over 6. All right, so that can be a little rough. So let's just go ahead and do this in a more classical way. Again, think about ASTC. You're here or here since you're, oh, no, I'm doing this wrong. No, I am, it's doing it right. You're here or here. You know your patterns. You know this thing. You know you know what ratio that is. That's opposite and adjacent. 1, 1. This one happens to be negative. Root 3, negative. Root 3, positive. You know this is 30 degrees. You know that's 30 degrees. So draw triangles too. 48. How many have I got left? 3. Shoot. Use the law of cosines. Find length. Kyle, I need 5 minutes. Kyle, need 5 minutes. Use the law of cosines. Find length of the side C in this triangle where A is 3, B is 3, and the measure of angle ACB is 120 degrees. You don't have law of cosines given to you. C squared equals A squared plus B squared minus 2AB cosines of angle C, which, by the way, is 120 degrees. All right. Don't know what C squared is. 3 squared and 3 squared makes A and B. Boy, this one ought to be pretty easy. 3 squared plus 3 squared minus 2 times 3 times 3. Cosine of 120 is something you can get from a unit circle if you'll draw it. 120 degrees is right there. It's back a half up root 3 over 2 if I remember right. So it's negative 1/2. 2 times 3 is going to be negative 18. Sorry, just say 18. There's a minus sign there. 3 and 3 makes 18. C squared is this. So C squared is 18 plus what, 9? So C squared is 27. Root 27. Easy peasy, Japanese. 2 to go. If the sine of x plus the cosine of x is a half, what is the value of sine of x times cosine of x? Well, that's interesting. That is interesting. What should we do? Pretty cool. Oh, they gave us a hint. Square both sides. Trust the hints. So sine of x plus cosine of x times sine of x plus cosine of x is a quarter. I need 5 minutes. I'm recording. I have sine squared plus cosine squared plus cosine x sine x plus another cosine x sine x. Okay, this is actually a pretty easy problem. Still equal to a quarter. This becomes 1. And then I have this. 2 cosines x sine x equal to a quarter. I subtract the 1. 2 cosines x sines x equals negative 3/4. And I divide out my 2. And I get that cosine x sine x is negative 3/8, which is exactly what they were asking for. And the last one, 50. Use the law of cosines to find the measure of angle A rounded to the nearest degree in the figure below. And again, we won't worry too much about that. So they want A. So this is kind of going to be like my C here, okay? 25 squared equals 32 squared plus 37 squared minus 2 times 32 times 37 times the cosine of this thing. So Old Faithful won't work right now because I don't have my lights on up front. But I can do 32 times 32, right? Plus 37 times 37. And let's see here. 25 squared times 25. I'm going to have 625 on the left. I'm going to have 2393 on the right, which I'm going to move over. What's 2 times 32 times 37? 2368. All right, so I do my subtraction. I get negative 1743 equal to negative 2368 cosines of A. I do my division. 1743 over 2368 is the cosine of A. And I know my arcs. So the measure of angle A is going to be the arc cosine of that number. And that's what would be expected of you, because you're not allowed to use a TI-84. So there you go. Barely made it. 7:45, classes start.